Hi everyone, this is Mrs. Hanson. This is Lesson 2-5, Rational Functions, Video 2.5.5. Our learning target for this video will be for students to be able to graph a rational function with common factors. Alright, so we've talked a lot about graphing rational functions already in the first two videos, and this time we are just going to discuss how we would graph a rational function with common factors. So if you look at the example here, determine any vertical and horizontal asymptotes, holes, which we have not discussed yet. We haven't discussed how to find or identify holes in a function. And we want to also find the intercepts for the function h of x equals x squared minus 9 over x squared minus x minus 6, and then graph the function and state its domain. So in order to identify any holes or common factors in the function h of x, we need to factor both the numerator and the denominator. So what we're going to do first is rewrite h of x in factored form. The numerator factors to be x plus 3 times x minus 3. Because positive 3 times negative 3 multiplies to be negative 9, and since we want no x term in the middle, we know that the two numbers we use are opposites because they have to add to 0. So, if you FOILed out x plus 3 times x minus 3, that would give you x squared minus 9. On the bottom, if we factor this quadratic trinomial in the denominator, we're going to get x times positive 1 and negative 6, right? Nope. I'll take that back. It's got to be a positive 2 and a negative 3. Positive 2 times negative 3 gives me negative 6, and when I add 2 and negative 3, it gives me negative 1. So, what you can see here is that we have a common factor of x minus 3 in the numerator and the denominator, so that factor cancels out. Now, that leaves me with the function x plus 3 over x plus 2. However, this cancellation of a common factor creates a hole in our graph whenever x minus 3 equals 0. So if x minus 3 equals 0, that means x equals 3. That is going to give me a hole in my graph. And that, again, a hole only occurs when you cross out a common factor in both the numerator and in the denominator like we did here. So we have x minus 3 on bottom and an x minus 3 on top. And since we canceled those common factors out, if I set that common factor equal to 0 and solve for x, that is the location of the hole in our graph. Now, left over is x plus 3 over x plus 2, which is going to give me a vertical asymptote. Since we still have an x plus 2 in the denominator, x plus 2 cannot equal 0. That implies x cannot equal negative 2. So, right now, I know that my graph has a vertical asymptote at x equals negative 2. And I have a hole at x equals 3. And what we're looking for is a horizontal asymptote. The horizontal asymptote, since my degree of my polynomial on top and on bottom, since we have a degree 2 on top and a degree 2 on bottom, then I divide the lead coefficients. So we have both functions there. We have 1x squared over 1x squared for our lead terms. Since these degrees are the same, we divide the lead coefficients, and our horizontal asymptote happens to be at y equals 1. Now, so we've done vertical asymptote check, horizontal asymptote check, we've identified the holes, And now the only thing we have to do is determine the intercepts of our function, which I will complete that on the next slide. Okay, so our function h of x, we've already identified asymptotes and our hole in the graph, but we still have to identify the intercepts here. Our x-intercept, or the zeros of our function, is where the numerator is equal to 0. So if I set x squared minus 9 equal to 0, that gives me x squared equals 9. And if we square root both sides, we get x equals plus or minus 3 as our solution. Both 3 and negative 3 squared give me a positive 9. Now, remember that when we factored this function, remember we got x plus 3 times x minus 3 all over x minus 3 times x plus 2. And since the x minus 3's canceled and we have a hole at x equals 3, the only 0 that we're going to have for this function, because this common factor cancels each other out, the only time or only location we are going to have a x-intercept at is at negative 3. Even though when I solve x squared minus 9 equal to 0, it tells me positive and negative 3, but remember we didn't know that positive 3 wasn't going to be a solution or a 0 because we didn't know there was a common factor until we factored out both the numerator and the denominator here. So the only x-intercept is going to be at negative 3. And if I go ahead and find my y-intercept, that is where the function is evaluated for x equals 0. So I get 0 squared minus 9 over 0 squared minus 0 minus 6. Negative 9 over negative 6 gives me 3/2. So we have a y-intercept at 3/2, which if I divide 3 by 2, I get 1.5. Okay, so I just want to point a couple things out here with the graph. Just to confirm that our y-intercept is at y equals 1.5. Our x-intercept is at negative 3. We have a hole at positive 3. 1, 2, 3. There's a hole there. Even though the graph doesn't show the hole, you can look at the table over here and it shows you in the table that at x equals 3 the function's undefined. So if you look at the graph, it's not going to show you that a hole exists. You have to confirm that in the table there. And if you look at our vertical asymptote, that occurs at negative 2. And we have a horizontal asymptote at y equals 1. So we have y equals 1 here, and x equals negative 2 for our vertical asymptote. Alright, it's time to check for your understanding. I want you to determine the vertical and horizontal asymptotes and holes of this function, k of x. So you're going to have to do some factoring in order to determine if you have any common factors, which is where you have holes present is when you have a common factor in both the numerator and the denominator. So you have 4 choices, A, B, C, D. Go ahead, work out the problem, and select your solution. Okay, so what we're going to do here is we're going to factor both the numerator and the denominator to check for common factors. The top is going to factor into x plus 5 times x minus 4. On bottom, we're going to factor into x plus 5 and x plus 2 because 5 times 2 gives me 10 and 5 plus 2 gives me 7. When I multiply to be negative 20, that's positive 5 and negative 4. And when I add positive 5 and negative 4, it gives me a positive 1. So, looking at our rational function here, I can see I have a common factor at x plus 5, which implies if x plus 5 is equal to 0, I have a whole at negative 5. Okay, so just take a glance at our multiple choice questions. We're going to have a whole at negative 5. And right, part A, or choice A, is not obviously the response, since choice A says there are no holes in the graph. Answer B says we have a hole at negative 5, 3. C says we have a hole at negative 5, 0. And vertical, or choice D says we have a hole at negative 5, 3 as well. I'm going to work out the rest of the problem here. Obviously, since I have a factor left on bottom of x plus 2, if I set x plus 2 equal to 0, I get x equals negative 2, which x plus 2 can't equal 0, because if it does, then we'll end up dividing by 0. So this tells me that we have a vertical asymptote at x equals negative 2. So if I look at my choices, it says vertical asymptotes at negative 5 and negative 2. That is not true. We only have a vertical asymptote at negative 2. And choice C is not a correct response, because again it says we have 2 vertical asymptotes when we only have 1. So I do know that D is my correct response at this point. I have identified vertical asymptotes and holes. My horizontal asymptote, because my degree is the same on top and bottom, I'm going to divide my lead coefficients, which 1x squared over 1x squared. If I divide my lead coefficients, 1 divided by 1 gives me 1. So I'm going to have a horizontal asymptote at y equals 1, which is what letter D states. So for sure, D is the correct response for this problem. Obviously, you could go and graph this function k of x. Make sure that if you're going to plug it into your graphing calculator, use parentheses around the numerator and separate parentheses around the denominator. And you should get a vertical asymptote at negative 2, horizontal asymptote at 1, and a hole, which you will not see on the graph, but you will see in the table at negative 5. So the function will state that it is undefined at x equals negative 5.